Okay, so in this problem, we're going to be taking a look at another free fall problem. And in this scenario, we have a stone that is shot straight upward with a speed of 80 feet per second from a tower 224 feet high. So the problem asks us to find the speed with which it strikes the ground. So I've highlighted the information that's given to us and also the main idea of the problem, which is to find the speed with which the stone strikes the ground. Right, so our given information is the initial velocity, first of all. V0 is equal to 80 feet per second. Y0 is equal to 224 feet per second. 224 feet. Now remember, when we're dealing with feet, when we're using, when our units are in feet, then we have to keep in mind that the gravitational acceleration, right, the rate at which an object accelerates due to gravity is 32 feet per second squared. So the problem asks find the final velocity v sub f, right, when y is equal to 0. The formulas that we're going to be considering here are going to be the free fall formulas, right? The height formula up here, the final velocity formula, right? V sub f is equal to v0 minus gt, and the two variations of these two independent formulas. Okay. If you look here, we have a diagram of what's going on. The 224-foot tower, the stone that's shot upwards at 80 feet per second, and the point where it lands with a certain final velocity, v sub f, right before the instant it touches the ground. So the way we're going to solve this problem, as usual, is by taking a look at the formulas that we have and seeing which one of these formulas most easily helps us to solve the problem. Right? If you take a look at the first formula here, the height formula, y equals v0t minus a half gt squared plus y0, this formula can't really help us to determine the final velocity. It can, but a little bit indirectly, because if you look here, yeah, we have pretty much all the information. We have v0, the initial velocity, gravitational acceleration, the initial height, right? But we don't have time, right? We can solve for time over here, considering that when y is equal to 0, right, we can solve for t, because this becomes a quadratic equation. And then maybe we can use that time and put it in here to solve for the final velocity. So we can do that, but it's a two-step process. So if we take a look at the other formula, the third formula down here, right, we have negative 2g multiplied by y minus y0 is equal to v sub f squared minus v sub 0 squared. So we have the initial velocity, we have the initial height, we have the gravitational acceleration, right? And we can deduce that y has to be 0, because that's when the stone hits the ground. It hits the ground at y equals 0. So we have everything here except for the final velocity, which we can solve, right? We can manipulate this equation and put all the other terms to one side and solve for the final velocity. So with that, we don't really need to take a look at this fourth equation. We know that this one can help us get the final velocity directly. So we'll go ahead and use equation number 3. So our equation is negative 2 times g multiplied by y minus y0 is equal to v sub f squared minus v sub 0 squared. So our initial velocity v0 is equal to 80 feet per second. Our gravitational acceleration g is equal to 32 feet per second squared. And our initial height, y0, that's going to be 224 feet. Let's not forget about y. When the stone strikes the ground, y is equal to 0. So y equals 0. Okay, so let's go ahead and plug these in. We're going to have negative 2. Let me write this in a different color. We're going to have negative 2 times 32, that's our g, multiplied by y minus y0. So that's going to be 0 minus 224 feet. And that's going to be equal to final velocity squared, and then minus v0 squared, where v0 is 80 feet per second. So that's going to be 80 squared. So minus 6,400. So we can solve for our final velocity. We're going to have v sub f squared is going to be equal to 6,400. And here we have the two negatives multiply out to become a positive. So we're going to have a plus 2 times 32 gives us 64. And then 64 multiplied by 224. And this gives us 20,736. And since we have velocity squared here, this is going to be feet squared per second squared. So we can solve for v sub f now. So we have the square root of v sub f squared is going to be equal to the square root of 20,736. And that's going to be equal to 144 feet per second. Okay, so this tells us that right before the instant that the stone strikes the ground is traveling with a final velocity of 144 feet per second. Okay, so this is right before it strikes the ground. So our answer, our solution for the problem is v sub f is equal to 144 feet per second. Now, if we wanted to be strict, we can say that v sub f is equal to negative 144 feet per second, which it is, because the negative sign means that the stone is traveling downwards. So technically, v sub f, the final velocity of the stone, is negative 144 feet per second. However, since the problem asks us to find the speed at which it strikes the ground, remember the speed is the magnitude of the velocity, so we don't really care about the negative sign here. The speed with which the stone strikes the ground is 144 feet per second.